Right on cue. All right, for a rundown, what's our topic for this week? Let's start there. Functions. What's the point of a function? Before we even get into the lab, what is a function? What are we using them for?
To do a specific task.
Do a specific task. Do a specific task, and basically, one thing that functions allow us to do. Some other advantages are that it allows us to give names or titles to that specific task, right? So like kind of breezing through what we see here, it's just a whole bunch of like stuff we don't even really want to look at. It just looked too crazy. It looked too crazy. Normally in these situations, when you see a whole bunch of calculations, like we don't want to see that. We want to see a function being called that does all of this stuff. So when we read it as humans, we say, okay, all of this stuff really is just doing whatever the formula name really is. You know what I'm saying? Like it'll actually make more sense to us. So that's how we want to approach this lab. Like, okay, I'm seeing some stuff being computed, but I don't really know why. I don't really know why. So we want to start putting this stuff into functions and give them names. So as we start to clean this code up, it'll start to read a lot better than what it does right now. Because right now it just look like a whole bunch of stuff that won't even compile, to be honest. So that's the first idea. First idea is you want to implement some functions. Now, how do we do that? How do we implement these functions? So the first thing you want to look for is repeated code. Repeated code. If you see the same thing being done a whole bunch of times, you want to think two things: function and loop. Function and loop. There's no point in me copying and pasting the same 4 or 5 lines of code if I can just put it in a loop and tell the loop to run that many amount of times. So those are the two ideas you want to carry with you throughout this lab. But I'm going to show how I approached it. I tried it this morning, and I'm going to show how I kind of got through it. We ready? So I'm going to start off with like the ideas and my approach. And then I'm going to expect y'all to kind of build off of it. And yeah, start putting the pieces together slowly but surely. So if I start reading this code from the top, I'm like, all right, I don't know what any of this crazy stuff is, so I'm gonna just kind of ignore it. I know it's starting some type of loop, but it's like, all right, I don't want to try to get rid of that. I haven't noticed that this is hurting our code. This doesn't look like it's hurting our code. So then I got some variables being created with no values. All right, cool. Down here, basically, we're reading from a file. A file is being read from, and that file is this vowels.txt. That is the file that we're reading from. It just has a bunch of numbers in it. And my assumption is those numbers are being put into this program and being used as like numbers to start like the calculations. I don't know what these calculations even represent, but I know our objective is to clean this code up. And so before I even start like cleaning it up, I'm gonna show you how I know when it's being cleaned. So if I run it, and this is just a new workspace or I just opened the lab. So if I run it, I see some output. We all see the output? Boom. Somebody said they got an error. Oh, all right. So I see my output. If I want to know if it marks, I'm going to try to mark it. Because technically this code should work. They're not giving us broken code. They just want us to clean up some existing code. So if I mark it, I see the following tests. I see 2 tests were run. The first one passed. The first one says it was an output test. It just makes sure that your output is accurate. It matches the expected output. In this case, we have a check mark. We see that the expected output is we're actually printed down here. So we're good with the output test. The next test which is this LLOC, which just means logical lines of code. This one is failing. This test is failing. It says you have excess logical lines of code. It wants you to have 6 lines. My bad. It wants you to have 6 lines, but you have 75. It wants you to have 6 lines, but we have 75 logical lines of code. So our objective is, and this is really only complaining about the main function, int main. It says error in main, excess logical lines of code. So we need to clean the main function up and get all of these 75 lines that it's complaining about down to 6. We need to clean it up. We need to clean it up. Yeah.
I don't know where to start.
Now we about to start as a class. About to start. I'm gonna show you I'm gonna give you the whoops, and y'all going. And yeah, we're gonna rock out from there. We're gonna figure it out. So even just reading through the code, right, you can see a lot of stuff is just repetitive. A lot of stuff is just repetitive. It's the same exact chunk of code just being copied and pasted a whole bunch of times. So it's not as scary as it really seems. Going from 75 to 6 lines is just about like, how do we do it? This is more so about how do we do it. But we see the problem off rip. The same thing is being done over and over again. So we can get this maybe down to just performing it once. We get rid of 70 plus lines easily.
So what, we're gonna do 3 functions?
We're gonna create functions for a lot of these steps individually, and we're gonna combine them. And that big function is gonna run right. Exactly. So we gotta start segmenting everything. What's up? So basically, why do we have the initial for loop that runs 4 times? Right. Right. So basically what's happening is we have the for loop that runs 4 times because, yeah, so basically, like I said, it's reading in these numbers and it's doing something with them. My assumption is, because I didn't create it, I think it's taking one whole line of numbers, using those as like the 4 constants, which are these things, C3, C2, C1, C0. Yeah, that's what it looks like. It looks like it's taking that file, and then it's assigning each of those 4 numbers on that row to each of those 4 variables. And then it's using those 4 variables all throughout the program. And so once one iteration of the loop goes, it goes to the next one, and then it's going to run the second row, and the third row, and the 4th row. But for each row, it needs to do all of those like calculations down here. Trust me, I have no idea what this is actually like, what formulas these are, but it's kind of besides the point. All we know is we got to extract them into functions and figure out, how they get through it. But the purpose of this lab is really to show you the pain point of having sloppy, messy code with no variable names and no function names. Like, you don't even want to do this lab because it looks so bad. That's the whole point of showing you bad code. All right, so we about to start. I'm going to show you how I would start. And I don't think my approach right now is going to take away a line of code necessarily, but it's going to show you how you can extract and create your own function. And with that process, you should be able to start little by little shrinking it. And then I think one step is going to get you to shrink it by a whole lot. Like one of those steps you're going to hit is going to get you to shrink it by a whole lot. So what I would do is I would read it line by line and say, all right, what's my first line of code that's like always repeating itself?
That first one.
like this one.
Yeah, that one.
Yep. So whatever this formula is, if I highlight it, I see all the additional highlighted lines, which means this is an exact copy for each of these lines. Question?
Could you make a new little tab that has this original code, so in case we get too deep into it and we mess up, we just have the whole thing we can just copy and paste back in there?
I mean, if you want, you can make a new file and do that, but I'm not even about to like dig deeply into it. I'm about to show you an initial approach, and I'm out. But you can always reset to scaffold, and that'll give you the original code. If you want to create another file, you can, and just copy the code there. But I'm not going to do it. So this is the line of code that we want to start with. This is the first repeating line that we have. So what I'm gonna do is I'm gonna pretty much just copy it. I'm gonna say, man, this is too hard to read, so I'm gonna just create a function for it. The sucky part about this is I don't know what this function is, so I can't really name it. I don't know what this formula is, so I can't really name it So I'm gonna just name it function 0. I'm gonna name it function 0. Until I figure out what it does, if I ever figure that out, I'm gonna just name it function 0. I don't know what it should return yet. I don't know what the inputs are yet, but I know the body of the function should be that repeated line of code. I want this function to do that repeated line of code. And I'm gonna take baby steps to get to completing this function and replacing that repeated line of code with my function that I'm creating. So everywhere I wanna use this function is just gonna replace that long line of code. So that's the first step. So all I did was I started creating my first function, and I'm gonna say to get rid of the following line, and I'm gonna paste that in there. So as we kind of build these functions out, I'm gonna keep track of what line of code the function is gonna replace. So boom, my first function is gonna get rid of that repeating line. So I'm gonna say, all right, I still need a return type. I still need some inputs, and I still need to return something for this function. So a lot of the key pieces is still missing. With my line of code right here, I know it's using a bunch of values. It's using C3, C2, C1, C0, and it's using some value called X underscore CUR, whatever that means. So there's 5 values that this formula needs to use. In order for it to be able to use some values, it needs inputs. So I know now I need 5 inputs. I don't know the data type that these inputs need to be, so I'm gonna go down to where this function was actually, or like where this formula was actually used. The first time I saw it used was on my line 25. It uses C3, C2, C1, C0, and X underscore CUR. So I'm gonna say, all right, so I can start adding inputs to my function. I need to know the data type of all of these values. So I'm gonna say, what is the data type of all the C values? They're all integers. All of these are integers. So I'm gonna roll with that. I'm gonna say, all right, I need 4 integers. So I'm gonna just call them the same thing. C3, C2, C1, C0. So now I'm able to use C3, C2, C1, and C0 because I said they're gonna be passed as inputs to this function. They're gonna be passed as inputs. The last value that we're trying to use throughout this formula is X underscore CUR. So I'm gonna say, all right, what's the data type of that? I go down to where that formula was actually using it, and I see X underscore CUR is a double. So now I know, okay, my function needs to also support a double. I could name it X underscore CUR, but actually I don't even know what this CUR part means, so I'm gonna just name it X, personally. I'm gonna name it X. So in my function, I'm gonna change X underscore CUR to just being X. So now this is saying So now I've taken this long line of code right here, and I'm using that as the basis of this specific function. So now this function is going to be responsible for computing whatever this formula is using 5 given values, 4 integers and 1 double. So if I have this formula and I'm adding and multiplying a bunch of integers and doubles, I know my result of this should probably be a what? A double. A double. So I'm like, all right, so this is probably going to return a double. It's going to return a double. So I've added my return type to this function. At this point, I've committed this function to returning a double, so I actually need to return a double. So how can I return a double in this function? Return, just put return in front of the whole thing. No, that was a statement. I'm gonna just return whatever all of this ends up equating to. I'm gonna compute the whole thing and return it back to the user. So at this point, this still hasn't given us any like clarity as to like what this thing does, but that's just because I'm just personally ignorant as to what this formula is in real life. I think it's a real like formula though, like to calculate something. I think this whole program is actually doing something like scientific or something mathematical. But due to my ignorance, I'm gonna just put function 0 as the name of it. So now that I've created this function, I need to use it. I created it for a reason. So remember, this function its purpose is to replace this long line of code. So everywhere I see that like bluish gray line, I should replace that with function 0 and put 5 numbers in it, 4 ints, 1 double. So I'm gonna start like this. This first one, I'm gonna say, I'm gonna comment this out before I just like delete it. So I know it was taking this whole thing and assigning the value to something called f underscore cur. So I'm gonna keep the first part, f underscore cur, but the value of it is gonna come from function 0. Because remember, function 0 is gonna do all of what this initially was. Right. It's just we condensing it and trying to make it read a little better. So I'm gonna say, boom, I'm gonna call function 0, but the problem is function 0 wants 4 integers and a double. So let's see what 4 integers and 1 double was it initially using. It was using C3, C2, C1, C0, and the double it was using was what? X underscore cur. Because we're just replacing this line right here. We're using the same values it was using. We just created a function to like encapsulate all of that logic. So we're going to use these values. At this point, I can delete that. And everywhere that I had this f underscore cur equals the long formula, I'm going to replace that line with my function. I think it occurs 12 times. So I'm going to go line by line. Every chunk of code that has it, I got to replace it.
Is there any way to like replace all of them at once? Or we have to do it in code?
I think it's a keyboard shortcut. I don't know it though. So let's see. So let's see if So every time you make some substantial amount of changes, you want to still make sure your code will mark and it says that the output is still correct. Because remember, the output should always remain the same. We just want the code itself to be way cleaner. We want the code to be cleaner, but the functionality should remain the same. So I'm going to mark it and hope it still passes that first test. All right, boom. So my first test is still saying the output prints correctly. The output still prints correctly. We still haven't gone down on our lines of code, but the output is still correct. So I'm gonna see what is it complaining about. It's saying when I created function 0, I have an excessively long line. Like, it's just complaining about everything. It wants my code to be so perfect, so I'm gonna try to get it there. It's saying I have 77 characters on this line. I have 77 characters on this line. So I need to apparently get the amount of characters down a little bit. It's complaining about this one. It's complaining about this line of code right here. So I'm gonna talk through like how I would kind of think about it. My first thought is, all right, what is this function actually doing? What is this formula supposed to be computing? It looks like it's doing some exponents and multiplying it by some like coefficient, and then it's adding it each time. The exponent is going down each time. I don't know the values of these coefficients, nor do I know the value of x, so I can't really do anything to the coefficient or x. So reading this left to right, I'm saying, all right, at some point, I multiply x, I raise x to the power of 1, which is kind of redundant because x to the power of 1 is just going to be x. So honestly, I can get rid of this piece, and I can save myself some characters if I just put x instead. I don't need to raise x to the power of 1 because that's just x. So what I'm going to do is, I'm going to get rid of this whole thing, and I'm going to just put x. I'm going to just put x right there. Instead of, well, x to the power of 0 is 0. Is 1? Oh, bet.
Anything to the power.
Bet. So, yeah, we can replace that with 1. So let's replace this with 1, and then we're going to replace the other one with x. That should get us down on amount of characters for that line. So let's see if it's still complaining. And let's see if our output still remains the same. Boom. So that got rid of that error. So now it's not complaining about how many characters are in this line, so we good. But now it's saying you still have 75 lines of code and you need to get it down to 6. So we've taken one step, like a half a step closer to getting this whole thing solved. But you want to follow this same process and saying, all right, where are my repeated lines of code? The next one I would probably be looking at is this one. I'm looking at this line of code and I'm seeing it's just being done all of these times. So it would probably help if we could just call a function and get rid of that line. And the TAs, I think, I ended up reading through this thing. They said they created like 5 functions. So out of that 5, I'm assuming we have 1 down. We got 1 down. So maybe we can do this one. Maybe we can do this one together. I'm not just going to like explain this one, but I'll lead it. I'll lead it if y'all help me. So if I have this line of code that's being repeated, what do I need to do to extract it? Create a new function. Okay. It needs to be a double. Okay, double. What I'm gonna name it? That's what I would do. All right, boom. So the body of this function should say what? What should the body of this function be? The body. The line, yes. All right. So now we're looking at what values does does this formula use? It's using C3, C2, and it's using C1. And it's using X underscore CUR, which we know is a double. So it's using 1, 2, 3 integers and a double. So what do I need to put in my parameter list?
For the ints, can't we just do int C3 comma C2?
Not when you creating parameters, nah. When you creating variables like here, that's perfectly fine. But nah, C++ not that smart to know you like, you know. So now we have parameters for all of the values we're trying to use. And we said it's going to return a double. So let me replace XCUR with the X that I use. So since this is adding 0, I feel like I don't need to do that. We're just basically trying to get rid of all the unnecessary stuff, but keep the functionality at its core the same exact thing. This part? Okay. So honestly, if this is doing C1 times 1, we probably don't even need the. So we could just make this X. Alright. So let's say this is our finished formula, right? How do we give this back to the user? Return the whole thing? Alright, and let's see. Huh? I think the 3 is a part of the. And so how can we see if this function actually still maintains the functionality? Okay. So I'm gonna add another. So as I'm like gonna be deleting stuff, I'm also still keeping track of what was deleted. So I never like, if at any point something stops running as expected, I can like retrace my steps a little bit. So all right, I know that basically this function 1 needs to be called. It needs to put some values in there, and I'm taking the return value and I'm assigning it to f underscore p underscore cur. So I'm gonna start with this. And I know function 1 takes some input, so I need to gather my inputs and put them in the function. So it takes 3 integers and 1 double. So I'm gonna put those same 3 integers in that same double that was originally being used, which was C3, C2, C1, and what was the double? X underscore CUR. Now I'm gonna delete that line of code. So we're starting to condense a little bit in terms of how many characters are on a line. I don't think we've gone down on lines of code yet, but we're about to. So I'm gonna just mark this and see if it still gives me the same output. Whew. All right, so we still got the same output. We maintain our green check mark for the first one. So now I know it's safe to start replacing everywhere that long formula was with function 1. I think I replaced all of them, so now I'm gonna mark it to make sure we still getting our same output. And notice how I'm not doing like super large chunks of tasks and then I check if it's still marked. Like every few tasks that I do, a few lines of code that I change, I make sure it still marks. So if at any point it doesn't mark anymore, I only gotta retrace like 2 or 3 steps. So I still got my green check mark. So now I'm saying, how can I optimize this a little more? So we getting our functions together, but now we gotta see how can we start eliminating lines of code. The next thing I would do, and this is probably the last hint I'm gonna give before it gets like too obvious of how to like really reduce it. So the third step that's repeating is what? The if statement. The if statement. What the if statement is doing is it's checking the value of this FPCUR, and if it's 0, then it's going to reassign the value to however you say that. It's going to reassign it to that. Otherwise, it's not going to do anything because there's no else. So I'm going to say, all right, this is everywhere this occurs, that's 3 lines of code that we could really be getting rid of and simplifying it down to 1. So I'm going to say, boom, I'm going to copy that chunk. Copy that chunk and see if I can create a function for it. But I'm going to see, what should this, let's see, does this return a double? What is this? What should this function return? We sure? So what is this function going to do? Because remember, we just said the if statement is the repeating step. So what is it going to return? The if statement? Oh, my bad. My bad. So so I'm gonna copy this to a comment. So boom, basically my comment is saying I'm getting rid of this if statement. I'm getting rid of this if statement with this function. All right, so in this function, right? In this function, do I need, you say I'm returning a double, so, but like what from this function would I be even returning? Because it's just an if statement. It's just a, 0 or the other number? Okay. So I could say, how would I alter this to do that? And remember, this is using some value that we don't have access to. So it's 2 things we got to do.
So like, wouldn't you just put the F underscore P underscore like here in like the where you're at right now?
Okay. All right, and what's the data type for that?
That's
I would say int probably.
You guessing? It's on the screen. No, it's right here.
It's a double.
Right. Right. Remember, I haven't touched this at all. I just copied it from int main. Int main created that variable as a double. So if I'm gonna try to use the value from that, then it needs to be the same type, which is a double. So I don't know what this FPCUR thing stands for. So I probably just I don't know. I name it FP or something. I just name it FP. And so I'm gonna say if FP equals 0, I can say return this thing, or I can just, if that doesn't happen, I can just return FP. Because remember, if FP isn't equal to 0, FP is going to remain unchanged. We only change the value of FP if FP was equal to 0. So I had my two return statements. That's how I can get out of this function. I'm either going to get out with a value of that 0.0001 or with the same value of FP.
I'm getting an error code on my function 1, but it looks exactly like yours.
Can't be.
My S
Can't be. I could take a look in a second. I'm gonna try to get through this last building block so we can see the code shrink. Then I can address like individual errors.
Was that for loop? Why are the underscores there?
So the underscores are in the for loop because it's basically saying we need to run the loop a finite amount of times, but we don't care about I. We're not using I anywhere in the code. For example, if you're iterating through a string, right, and you want to know if the character at a certain index is a certain letter, you need I because you're going to say string at I. I is valuable in that case. In this case, we're not doing anything in here with I, so we just put in the underscore to say this loop it never uses the counter. It never uses the counter. It's going to do it 4 times, but we're not telling you what the counter is, so you know the counter is not important. The counter is not important here. So I got function 2. Function 2 is going to take in a value, and if that value is 0, it's going to return 0.0001. Otherwise, it's just going to give you the same value back. So now I can start getting rid of these 3 lines of code. Because remember, we're trying to condense int main down as small as possible. So when I see this, I'm saying, all right, this is trying to alter the value of f underscore p underscore cur. So I'm going to say, cool. Let me comment that out. Just highlight it and hold control and press the question mark. So I'm going to say fpcur is the value we're trying to change. So I'm going to call function 2. And I'm going to give it the value of fp cur. And what this is going to do is say, when I pass the value in, it's going to jump to function 2. It's going to say, all right, is this value a 0? If it is, I'm going to return you 0.001, or it's going to give you back the same value of fp. Either way, that should be the new value of fp cur. So now I've condensed these 3 lines down to 1.
Isn't FPCUR already equal to function 1? Okay.
Maybe it was another. Oh, I think, yeah. So it's supposed to get a value from here, and then I think it's supposed to then get a new value. Like using that prior value is now getting a new value, if I'm not mistaken. Yeah. So just like on this like kind of untouched chunk right here, fpcur does get a value from function 1, which is perfectly fine. Then it's saying, all right, with that value, let's see if that is a 0. If it is a 0, we're going to change it again.
Okay.
Again, I don't know what this whole formula is supposed to represent, so it's hard for me to like justify why it's doing it this way. But just accepting this as some important mathematical thing you was thrown into at your internship, you don't get to dictate and say like, I don't want to do it this way. We just know we gotta condense it, right? So I'm gonna check the value of fpcur. If it's 0, I'm gonna change it. Otherwise, I'm gonna keep the same value of that variable. Keep the same value. So everywhere I see this if statement, I can start replacing it. So let's see where I should replace at. Did I go back? Alright, okay, let me see. Alright, bet. So now, I mean, it still looks like a lot of code, but we've condensed something. So I'm gonna try to mark it and make sure my first test still passes, that the output is still the same. Otherwise, we gotta figure out where the error is. And then I'm gonna see if the lines of code like condense, and if so, by how much. So I still have my first check mark saying that the output is still the same. And we went from 70 something lines down to 63. Just by condensing that if statement, we went down to 63, man. We halfway there. We halfway there. So next we need to see what else we can start condensing. What I would probably do if your code looks just like this and you see like 20 some lines stacked up, I would start putting white space in between the chunks that look exactly the same, so you got a whole bunch of segments that look exactly the same, and you can figure out, all right, if I'm doing the same thing 10 times, can I just run a loop to do the loop 10 times and put that chunk in the body of that loop? I'm not going to go into how to do that because that's like the essential part of the lab. But showing you the process of, all right, create some functions that simplifies this down a whole lot is the idea you want to go with. And I guess I can show like one more thing. I can show one more piece of this. Let me see where I would do it at. So I got X curve. I think it's right here.
Hey, who did this live?
Oh, murder.
Make sure that nigga receives Angel Cake for Christmas.
I'm recording, bro. You about to deck my monetization. All right, so what I just did, right? What I just did was I went through that big chunk and I noticed that this thing is the same exact thing as this thing, is the same exact thing as this thing if I put a new line after function 2. So like each of these 3 chunks are the exact same thing. So your mind should be thinking, throw it in a loop. That will get rid of a significant amount of code. And remember, this whole thing was just repeated endless times down there. So once you do the whoops, hey, I feel like you're going to be down to about 10, 15 lines. At that point, you can start figuring out how to like really condense it down to the 6. But this is what you should have so far. This is the idea you want to have so far. Oh, all right, hold up. It's like an error?
Yeah.
What does it say?
It says S for 1 is negative 9.
Oh, so your calculation must have changed. So you must have like miscopied or like maybe even if you deleted like one line or you used the wrong variable somewhere, it's gonna throw the whole calculation off.
Or if I like switch the
Position.
order,
Mm-hmm.
yeah. Okay,
Yep.
problem.
So you might just gotta like start backtracking a little bit. Any questions about the idea before I go into individual like issues?
I just want to see how you spaced it out.
Okay.
I spaced it the wrong way. So on X. Okay.
So it's like 4 lines that are kind of like repeating, and it's some line, then function 0, function 1, then function 2. It's how I did it. All right.
I just want an easy laugh. I got an easy laugh.
All right, so we cool on the idea.
Yeah.
We at least see like some type of starting point.